The second problem from weekly contest 103. The problem definition is really big, so let me quickly read through that. We are given a n into n square matrix named board where the cells are labeled from 1 to n square in a booster feeder style starting from the bottom left of the board and alternating direction each row. So our first row is from left to right, and the second row is from right to left, the third row is from left to right, and so on. We start on square 1 of the board. In each move starting from square current, do the following. Choose a destination square next with a label in the range current plus 1 to current plus 6, where current plus 6 not greater than n square. So what it is saying is that in each move, after rolling the dice, we can move from our current position to the next 6 positions. Now this choice simulates the result of the standard 6-sided dice roll. There are always at most 6 destinations regardless of the size of the board. Okay. If next has a snake or ladder, we must move to the destination of the snake or ladder. Otherwise, we move to next. The game ends when we reach to the square n square. A board square on row arc and column C has a snake or ladder if the value of the board at that position is not equal to -1. The destination of the snake or ladder is the value of the board. Square 1 and n square do not have snake or ladder. Okay, note that we take a snake or ladder at most once per move. If the destination of the snake or ladder is the start of another snake or ladder, we do not follow the subsequent snake or ladder. This line I will explain a bit more detail later. So what it is asking from us is that return the least number of moves required to reach the square n square. If not possible, then we need to return -1. So the point, the least number, this point is very important because we know that shortest path or least number, minimum number, whenever these words are mentioned, most of the time we use breadth first search or level order traversal. So we know that this problem can be solved using breadth first search or level order traversal. Now let's see the example so that we can understand the problem properly. Here we are given a square board, and the value of the square is alternating in each row. Okay, so we have to find the least number of moves that is required for us to reach from 1 to 36. So in the beginning we start at square 1 and we decide to move to square 2, must take the ladder to square 15. So after taking one move we are at 15. Then after taking the second move we are from 15 to 17 and at the snake's head, so we move to 13. So after taking two moves we are at 13. Then we move from 13 to 14. So after taking 3 moves we are to 35, because when we are at 14 we go to 35. So after a 3 move we are 35. So then from 35 we take another move and reach 36. So the minimum number of moves that is required to move to reach 36 from 1 is 4, and we have to return 4 here. This note is telling us that we can take snake or ladder at most once per move and cannot take the subsequent snake or ladder. There is an example as well, so let's see the example so that we can understand this note a bit clearly. Here we have a board that is -1 3 and -1 4, and I have written the position of the board, that is 1 2 3 4. Our task is to move from 1 to 4 in a least number of move possible. So what I'm going to do is from -1 I'm going to move to the next position, that is 2, but the value of 2 is 3. So there is a ladder that is helping us to move from 2 to 3, and after reaching 3 we see that the value of this cell is 4, and so we find that there is another ladder that is helping us to move from cell 3 to 4. But the note that the point that note is making is that we cannot take subsequent ladder. So if we take a ladder from 2 to 3, then we cannot take another ladder from 3 to 4. That is the point. Now let's see how we can solve this problem using BFS or level order traversal. Here I have drawn a tree that is from starting point 1 we can move to the next 6 position, that is 2 3 4 5 6 and 7. Similarly from 2 we can move to next 6 position, that is 3 4 5 6 7 8. Similarly for 3 we have another 6 position that we can move. Similarly for 4 we have some positions that we can move to. From 5 we also have some position that we can move to. Similarly for 6 and 7. Now if we follow the level order traversal, then we're gonna traverse the tree in a level by level. That is, we're gonna traverse the first level, 1, then we're gonna traverse the second level, this one, then we're gonna traverse the third level. Similarly, we're gonna traverse the fourth level afterward, and those level indicates the move that is required to for us to reach the cell. Now if we find the cell that is we are searching, that is the ending cell, then we immediately return the value of the level, because the level indicates the move. And this is the most efficient way to write this algorithm, because we are not traversing any square that is not required. As soon as we find the target square, we are returning the value of the move. Here we're gonna need to take the length of the board first. We're gonna need a queue. Deck is a double-ended queue, so we can use it as a queue as well. Now I need to append the first value to the queue. The value that we are going to append is the value of the square and the value of the move. Initially the value of the square that where we are going to start is 1, and the move that is required to reach 1 is 0. We need a visit set to keep track of the square that we have visited. Now let's write the BFS part. While we have item in our queue, we just gonna pop left from our queue, so square and move. After popping the leftmost item from our queue, we're gonna go to the next 6th position that we can move from our current square, that is for I in range 1 to 7. Then the new square value is gonna be square plus I. Now we need to find if this square, if the row and column of the square is having a value -1 or any other value. So to do so, we need to find the row and column first. So let's see. Let's make a function that's gonna give us the row and column from the value of the square value, that is from square get row and column. And this function is gonna take the new square value and return us the row and column value. So let me define this function. Okay, I have a little bit typo. So for right now, let's just return 0 0 from this function. Then we're gonna come back and finish this function. Now after getting the row and column value, we're gonna check if the board of row and column is not equal to -1. If that is the case, then the value of the new square gonna be the value of the board. After doing so, we're gonna check if the value of the new square is our target value or not. So what is our target value? Our target value is the n square that is because our board is a square matrix. So let me check that. So a square n into n. If that's the case, then we're just going to return the move. But in this case, the move is to reach this square, not the new square. To reach the new square, we need to add 1 to our move. Now if that is not the case, then we're just going to check if the new square is in our visit set or not. If it is not in our visit set, then we're just going to append it to our visit set. And we're going to add this to our queue. That is new square and the move. Now after completing this while loop, if we didn't return the move that is required to get to our target value, then we can return -1, because then we cannot reach our target value. And if we cannot return our target value, then we need to return -1. Now let's get back to this function. From square, get row and column value. Now as we are getting the square value, let's see here. Here we can see that we are starting from 1, but our row and column is indexed from 0. So what we need to do is subtract 1 from our square value. So let me do that. Now after subtracting, our row is changing for after 6 values, so we can just divide it by 6, and that's going to return us the row value. And as our column is changing after every square, so we just need to mod our column. So let me do that. Skew -1 and modulus of 6. But as this is a generic algorithm, so we are not going to use 6, because our length of the board is n, so we're going to use n here. Now there is another catch, that is our column is alternating after every row. That is, this one is from left to right, the first one. The second one is from right to left. So we need to accumulate this one as well. So what we can do is check if our row is odd or even. If it is odd, then we know we need to change our column. That is, our column value is going to be reversed. If it is 0, then it's going to be 5, and if it's 5, then it's going to be 0. So what we can do is n minus c minus 1. Now this should work. Now let's see if this works or not. It is returning me 5, but the answer is 4. So let me see what I have done wrong. Okay, so what I haven't done is I have considered the row and column to be 0 0 for our initial case. But here we can see that in the beginning you start at square 1, that is row 5 and column 0. So our row is given in a reverse order. So what we need to do is reverse our row. So to reverse our row, we just need to reverse the board. So let me just do that. So board dot reverse. Now let me run it again. Now we are getting the answer that is expected. Now let's submit and see if this is accepted or not. Yeah, this one is accepted.